All right, so this is 2.2c.2, solving quadratics by completing the square when a is not 1. Your instructional objective is you're going to be able to follow the steps for completing the square to solve a quadratic equation. Okay, so we're going to go to your note page, and we're going to fill out that first box, which I got to tell you, which is not that. That's the answers to tonight's homework. So you could pause it and write it down if you're at home. Step 1 is to divide all terms by a. Now, we didn't see that step on our last set of notes when a equals 1, because dividing everything by 1 wouldn't change anything. Okay? I actually think that step 1 and step 2 are interchangeable steps, and I typically will do step 1 before I do, or step 2 before I do step 1. So what I like to do is this first, write the equation where the x's are on one side and the constant is on the other side. And I'll typically do that before I then divide the a off of the equation. Okay, x is on one side, constant on the other. All right, and once we get it in the right format and we've divided the a out, we create a perfect square trinomial. This looks familiar, right? By cutting b in half and squaring the result. Then we add the number to both sides of the equation to maintain balance. After we do that, we factor the perfect square trinomial and combine like terms. And then lastly, we created the perfect square trinomial so that we could apply the square root property, which you could probably write as the square root property if you wanted for a notation. Okay, so that's the format that we are going to follow. And I think what I'm going to do is I'm just going to make this a little bit smaller. No, that's kind of made a mess out of things. So let me clear that out. Okay, so we're going to start with this example, no fractions required. So it's not so cumbersome to solve a quadratic using the complete the square if you don't have fractions once you get started. Okay, first what we want to do, like I said, do step 2 before we do step 1, is to get the x's isolated and the constant on the other side. So we're going to add 14 so that we get 6x squared minus 12x, leaving open a space for completing the square, equals 18. Okay, and now we're going to divide by the a term, which is what? So we're going to divide everything by 6 so that we can get it to where a term is, a is 1. So minus 2x equals 3. So much easier to look at that, right? So much easier to look at. So we're putting it in the right order and then dividing the a out of all the terms. It's still the same equation. It's just a lot simpler to look at. Okay, now we're going to cut our b term in half. So half of negative 2 is negative 1, and we're going to square it. So we're going to add 1 to both sides because we're squaring our b term. Well, we're squaring half of our b term. So I'm completing the square here on this side. I just created a perfect square trinomial, but I have to balance my equation. Whatever I do to the left, I do to the right. Okay, so now let's factor. Next step is to factor. So factor in your perfect square trinomial. That would factor to x minus 1 quantity squared equals 4. It's not looking so bad, right? It's not horrible. Now, of course, we're going to apply the square root property. plus and minus the square root of 4. Don't forget your plus minus. I'm moving up for those of you that are in the back. Okay, so we get x minus 1 equals plus or minus 2 by simplifying our square root on both sides. Now we're solving for x because that was our goal the whole time, is what is x? So x equals 1 plus or minus 2. So what I'm going to do is I'm going to color code my answers. So when I add 1 plus 2, I get 3. So that was me doing my math over the top of the plus minus. So I decided to add them. Now I'm going to go back. I'm changing colors. And I'm going to do my math going under. So I'm going to do the subtraction because it's under. So 1 minus 2 is negative 1. And there are my solutions. And I'm already going, I so would have rather factored that. I got 3 and negative 1. I could have factored that. But that's okay. You're seeing that complete the square. It works. It's just cumbersome. Okay, so it's not bad when when A divides out, it doesn't create fractions. Okay? All right. So the next two situations that I've presented to you both require fractions, but they incur different types of frustrations. Okay, so first let's take a look at our problem on the left. So we have 10x squared minus equals negative 6x plus 16. It's not in the right form. So I'm going to want to add 6x and put it over here so the x's are on the same side. So 10x squared plus 6x, leaving open a space to complete the square, equals 16. Okay, and then what I have to do, I've got in the right format, I have to do what? Divide by 10. I have to get the A gone. Bye. See you, 10. Bye, Felicia. Irrelevant. Okay, so x squared plus, simplifying your B, 3/5 x, so that's your B, there's your x, equals 8/5. And you can see frustration occurring, yes? You're going, great, I don't want to do this. That's all right. You can do it. Lots of unpleasant things you got to do in life. All right, so let's cut our B term in half. What did I tell you was the easy way to do it? Double the denominator, so 3/10 squared. Okay, so we're going to add what to both sides? 900s to both sides. Good, because we're completing the square on the left, but we have to treat the right the same way we do the left. Okay, and I'm coming over here to leave space for everybody that needs to see in the back. So we're going to factor your trinomial here. So x plus 3/10, quantity squared. Remember, it's just a square root of 900ths, which is 3/10, equals 169 hundredths. Now, how did I get that, you're wondering? I've been doing this problem all day, so I just knew. But first time I did it, of course, I made my denominators because I have to combine like terms. I went times 20 times 20, so I'd get 100 in the denominator. So that was 160 plus 9, 169. Okay, so that's how I did that. It wasn't that bad of a situation, but it is a little bit annoying. Now we square root both sides. Apply square root property, plus or minus square root of 169. And I prefer to really separate my numerator, my denominator when I'm doing square root, as you know. Okay. And then we're going to apply our square root property, cancel that out, equals plus or minus square root of, nope, 169 is a perfect square, 13 over 10. Yes?
So don't simplify, because I know 169. I asked you 169 simplified is 13.
So you just, went straight from here to here.
Yeah.
I'm okay with that.
I just like the
Oh yeah, don't do that. Yeah, be careful. All right, now we just have to move, right? To isolate the x, so we're going to subtract 310 and put it on that side. I'm going to move this out of the way, out of our screen, and I'm going to write my answer over here. So we get x is equal to negative 3/10 plus or minus 13/10. So they have the same denominator. Do you agree? So if I go over the top, I get negative 3 plus 13, which is what? 10 over 10, which reduces down to 1. So I'm going to redo that. And then I'm going to go back and go under and do my negative 3 minus 13, which is negative 16/10, which I in turn would have to reduce to negative 8/5. So final answer would be negative 1, not negative 1, 1 and negative 8/5. So you can see how clumsy it is. It's messy. You've got more space to write. My pen's so fast, it takes up so much space to write. And there you have that one. Okay, the last one we have to do, it creates fractions as well, but it creates a really different frustration. It's a little easier to solve, but the answer is frustrating. So let's take a look at this one. So we're going to rearrange it so the x's are on the same side. So I would say that I would write this as 4x squared plus 16x. I'm leaving my space to complete the square equals 75, right? Because we would add 16x to that side, add 75 to that side. And then divide by 4. All right, so I'm going to divide everything by 4 and simplify. So that leaves me with x squared plus 4x. That feels better. Happy about that. Equals 75/4. Not so happy about that. But at least it's not my b term, right? Okay, so now we have that. We're going to cut our b term in half. So half of 4 is, so 2 squared is, so we are going to add 4. Hey, I want red. Thank you. Add 4 to both sides. So we completed the square on the left. And then, of course, we have to treat the right the same way. Okay, so now we're going to factor. So this would factor to x plus 2 quantities squared equals 91/4. And again, if you're wondering how I did that, of course, I just tucked a 1 under that, did times 4 times 4. So 75 plus 16 is 91. Okay, now applying my square root property. I'm going to come over here so people can see. So square root of x plus 2 quantity squared equals positive and negative square root of 91 over square root of 4. Definitely want to separate those because 4 is a perfect square and 91 is not. So we get x plus 2 equals plus or minus square root of 91 over 2. So actually this one hasn't been horrible, but it's about to get annoying. So we're going to subtract 2 to solve for x, right? And we get x is equal to negative 2 plus or minus the square root of 91 over 2. And while that answer is correct, it's not the proper form. And I'm walking away from my computer and I'm not wearing my microphone. I never wear my microwave. That's bad for me. Okay, I'm not wearing my microphone. Sorry. So it's not technically not wrong, but it's not the proper way to write the final answer. So what we have to do is we have to give these common denominators. So that's frustrating, and you will have to do that today. So we're going to just make them both have a 2 by multiplying your negative 2 by 2, numerator and denominator, and we get x is equal to negative 4 plus or minus the square root of 91 over 2. And this, I'm going to put a heart around it. We love it when we get the answer right. Is the final answer. And you know I want you to write it in solution set. So I'm going to do that for video purposes. -4 minus the square root of 91 over 2, and -4 plus the square root of 91 over 2. Okay, and so you see the different frustration in that one? Is that you get all the way done and your answer's not in the right form. And it takes practice to learn that you need to address that situation. Okay, so that is our notes for today. I'd certainly like you to summarize them, do your reflection for tomorrow, and do problems 1 through 10. And I'm going to provide the key for answers 1 through 10 on Canvas, so that if you're, while you're working on your homework, you can check your work as you go.